Have you ever wondered what your body is made of? It's made of atoms, but how do these atoms stick together? What is the atom made of? That's why I picked my main inquiry question as, in what ways do protons and neutrons affect the structure of an atom, and how are they being used to advance proton therapies? The answer to this question in simple terms is that protons affect the structure of an atom because they balance the charge in a nucleus. Protons have a charge of +1 and electrons have a charge of -1. The protons balance the nucleus by ensuring electrons don't make things too negative. But protons repel each other using the electromagnetic force, so the nucleus would just rip apart without protons, which is why there is a strong force. The strong force is one of the things holding the nucleus. It is more powerful than the electromagnetic force. The electromagnetic force is the force that states that protons repel each other. It also states that electrons repel each other. Because of this, the atom does not burst because the strong force is there. The only reason the strong force works is that there are neutrons and protons. So if the atom removes too many neutrons, the strong force would slowly get weaker and weaker until the electromagnetic force is stronger than the strong force. Protons are essential to the structure of an atom. Without protons, the atom will fall apart. Protons help because protons have a positive charge while electrons have a negative charge. Because of this, protons are essential to the atom because if the atom has a really big charge, it would be very unstable. But if the charge was 0, it would be extremely stable. Also, research has shown that the most stable atoms are when the number of protons and electrons are equal. Also, a nucleus of only multiple protons would be certainly radioactively unstable. It would release some sort of positively charged electron from a proton and add a negatively charged proton. Neutrons are also essential to the atomic structure. The force that holds the atomic nucleus together is known as the strong force. Protons are positively charged and repel each other by the electromagnetic force. The reason that the positive nucleus doesn't fly apart is because the strong nuclear force, which acts between protons and neutrons and glues them together. This force is called the exchange of gluon, acting between quarks, which are the subatomic particles that make up both protons and neutrons. Removing enough protons from a nucleus would decrease the strong force while increasing the electromagnetic force. Let's take a look at some real-life uses of protons. Protons can be used in the field of medicine. 3D conformal radiation therapy, which shapes the radiation beam to match the shape of the tumor. Intensity modulated radiation therapy is very similar to 3D conformal radiation. It is used to treat cancerous and non-cancerous tumors. Volumetric modulated radiation therapy is a novel radiation therapy technique that delivers the radiation dose continuously as the treatment machine rotates. Image-guided radiation therapy uses imaging during radiation therapy to improve the precision and accuracy of treatment. Here are only a few. There are so many more types of radiation therapy. All these types of radiation therapy are being used to treat different types of cancer. There are so many places trying to improve proton therapy. For example, Memorial Sloan Kettering Cancer Center says that the goal is to achieve the shortest path to the distal tumor edge while minimizing passage through complex tissues. In conclusion, protons and neutrons are essential to the structure of an atom, and many people are trying to advance proton therapy. You can prove this by asking these questions. How do protons help bind the nucleus? How do neutrons hold the nucleus intact? How are protons being used in other kinds of radiation therapies? And how are protons being used to advance proton therapies?